March 10, 1944, Rechlin Airfield, Mecklenburg, Germany. The morning fog clung to the airfield like a veil, softening the outlines of hangars, cranes, and grounded aircraft that stretched along the frozen runway. Diesel engines rumbled in the distance as a small convoy rolled toward a hangar marked with a single black eagle. Inside, under the cold glow of overhead lamps, engineers and officers gathered around a new arrival, a fighter plane whose polished aluminum skin bore the faded white star of its enemy. For months, German radar operators had logged reports of Allied fighters appearing impossibly deep inside the Reich, far beyond the range of any single-engine aircraft known to exist. They had seen blips materialize near Berlin, over Magdeburg, even as far east as Poznan, then vanish again, heading westward toward the Channel. The assumption had been error or trickery. But the wreck on the flatbed truck before them was proof that the impossible had already happened. The aircraft was an American P-51 Mustang, captured largely intact after a crash outside Brandenburg 2 days earlier. The pilot had died instantly on impact. His flight maps and oxygen mask were still inside the shattered cockpit, frozen in place by the March cold. To the engineers assembled at Rechlin, this machine was not simply wreckage. It was a riddle carved from aluminum and ingenuity, one that had to be solved before the war slipped further from their grasp. Rechlin had long been the nerve center of the Luftwaffe's technical intelligence program, a place where captured aircraft were dissected, tested, and flown to expose the secrets of Allied innovation. Here, every inch of a foreign plane was measured, weighed, and recorded with mathematical precision. Technicians in gray coveralls moved silently beneath the fuselage, unbolting panels, draining fluids, photographing components. Major Hermann Voss, one of the Luftwaffe's leading technical evaluators, oversaw the examination that morning. A veteran engineer with a surgeon's patience, he traced his gloved hand along the Mustang's smooth metal skin and frowned. The aircraft seemed too light, too aerodynamic, its surfaces nearly seamless compared to the riveted plates of German designs. The shape was clean, deliberate, built not for brute strength, but for endurance. On a table beside the hangar wall lay the pilot's navigation chart. The line drawn in pencil began at Debden Airfield in England, curved eastward across the North Sea, and ended over Berlin, then back again along nearly the same route. A full round trip of more than 1,000 miles. To the men at Rechlin, it was an absurdity. No fighter powered by a single engine could fly that distance, dogfight, and return home. Even with auxiliary tanks, the mathematics of range and consumption rendered such a mission suicidal. Yet the Americans had done it, twice in 1 week. The reports had arrived from the front in rapid succession. On March 4th, the U.S. 8th Air Force had launched a limited bomber raid toward Berlin, escorted, unbelievably, by single-engine fighters. 2 days later, a larger formation struck the capital in daylight, shielded by swarms of P-51 Mustangs. Pilots of the Luftwaffe who engaged them swore under oath that these fighters fought with full power, pursued interceptors for miles, and still had fuel to spare. The contradiction tore through every established assumption in German aerial strategy. Fighter escorts had always been a limiting factor. The further bombers flew, the more vulnerable they became once their short-range escorts turned back. The Luftwaffe had built its entire defense system around that predictable moment of weakness. But now, the enemy had erased the gap. The front could no longer retreat behind distance. Inside the hangar, the Mustang's inspection proceeded methodically. Engineers cataloged its internal tanks, 2 in the wings, 1 behind the cockpit. The numbers were tallied, converted from gallons to liters, calculated against known fuel burn rates for the Packard-built Merlin engine. The arithmetic came back cruelly consistent. Even with every internal tank filled, the aircraft could fly barely enough to reach Berlin, and certainly not enough to fight there and return. Something was missing. Voss ordered the underwing pylons examined. Each one bore a simple fuel line coupling, evidence that external tanks had been attached. Drop tanks were not new. The Luftwaffe had used them since the Battle of Britain, but none had ever granted this kind of reach. The Germans needed to find one intact. 3 days later, a courier brought word from the countryside north of Berlin. Farmers had reported strange metallic cylinders lying in their fields, coated in silver paint, dented but intact. Recovery teams were dispatched. Within 48 hours, 2 examples arrived by truck at Rechlin. The engineers crowded around them, expecting aluminum shells or pressed steel containers. Instead, what they found defied logic. The tanks were light, too light. Their surfaces felt oddly warm to the touch, not cold like metal. When a technician scraped a small patch near the tail cone, the silver coating flaked away to reveal a fibrous brown material beneath. It wasn't metal at all. It was something layered, organic, and faintly rough, like dense cardboard. The room fell silent. Someone fetched a small saw and began cutting through the surface. The blade sank easily, releasing the faint scent of resin and burnt cellulose. The tanks were made of paper. Dozens of eyes turned toward Voss. The discovery bordered on absurd. A paper fuel tank. One that had survived the weight of fuel, the stress of flight, the cold of altitude? Impossible. Yet there it was, tangible and real, resting on the hangar floor. Layers of thick craft paper laminated with some unknown resin, shaped into a cylinder roughly a meter long and a half-meter wide. Inside, faint traces of golden lacquer glistened under the inspection light. A sealant, perhaps, to prevent gasoline from dissolving the walls. The engineers documented every measurement: diameter, wall thickness, internal baffles, mounting lugs, weight. Their calculations showed that each tank held roughly 400 liters, about 108 US gallons. 2 such tanks would more than double the Mustang's range. The numbers finally balanced. The mystery of the impossible mission had been solved, yet the explanation raised a deeper question. Why would a nation capable of producing thousands of tons of aluminum build fuel tanks out of paper? To the men at Rechlin, the idea was both brilliant and terrifying. It spoke not of desperation but of abundance, a willingness to reserve metals for aircraft, engines, and armor while outsourcing auxiliary components to factories that needed no metal at all. Paper mills, packaging plants, even furniture workshops could build these tanks by the thousands. No welders, no riveters, no specialized tools, just adhesive, molds, and heat. As the engineers compiled their report, the realization took hold that this single object represented more than a technical curiosity. It was a window into the enemy's industrial soul. The Americans were not merely designing better machines, they were designing better ways to make them. Outside, the afternoon sun finally broke through the mist, casting a pale sheen across the snow-dusted runway. In the distance, Luftwaffe fighters warmed their engines for another day's defense of a sky that no longer belonged entirely to them. Above that sky, invisible to the men below, the contrails of another American formation drifted eastward. Somewhere among them, hundreds of paper tanks hung beneath their wings. Temporary, expendable, yet decisive in what they symbolized. As evening settled, the staff at Rechlin filed their preliminary summary. It contained no emotion, only figures and diagrams, yet beneath the sterile numbers lay a dawning recognition. The enemy's advantage was not just range or speed. It was method. It was the ability to turn something as humble as paper into a weapon of endurance. The following morning, more trucks would arrive, more fragments to study, more evidence to measure. But for those who had seen the first of the paper tanks under the hangar lights, the conclusion was already forming quietly in their minds. This was no accident of innovation. It was a system so vast that it could afford to throw away what Germany struggled to build. And as the hangar doors closed against the night, the engineers of the Reich's most secret testing field realized that the war they were fighting had already shifted from the skies to the factories. By the second week of March 1944, the discovery at Rechlin had already spread quietly through the upper circles of the Luftwaffe's research directorate. Copies of the preliminary analysis reached Berlin within 2 days. Each page bore the same understated conclusion typed in neat script. External auxiliary tanks constructed from cellulose laminate impregnated with resin. Estimated capacity, 400 liters. Non-metal composition confirmed. In the corridors of the Reich Air Ministry, the finding provoked disbelief more than curiosity. Metal was sacred in wartime Germany, accounted for, rationed, guarded. The thought that an adversary would choose paper and make it work seemed almost mocking. To officers steeped in precision craftsmanship, it felt like blasphemy against engineering itself. Yet the data from Rechlin left no room for doubt. At the airfield, the tests intensified. Technicians filled one of the recovered tanks with aviation fuel to study leakage and pressure tolerance. The laboratory thermometer hovered just above freezing, yet no seepage appeared for hours. When the temperature rose later in the day, faint dark stains began to form along the seams. The resin softened. Within 6 hours the tank began to sweat amber tears of fuel. The conclusion was immediate. These were single-use devices, meant to serve only through the outbound leg of a mission. To German planners, that limitation was not a weakness, it was a revelation. It proved the tanks were expendable by design. They did not need to be retrieved, repaired, or stored. They existed for one flight, then vanished from inventory. In that simplicity lay the frightening efficiency of a mass-production mind. The intelligence section compared photographs of American fighter formations taken from gun camera film. Dozens of small shapes glinted under the wings of P-51s as they crossed the clouds. Analysts counted 2 per aircraft, all of identical proportions. The scale implied thousands manufactured and distributed within weeks. Every day that those silver shells detached and tumbled toward German soil, they announced an industrial truth. The United States could manufacture and discard what Germany could scarcely afford to build once. Major Voss ordered chemical analysis of the resin. Samples scraped from the tanks were heated, weighed, dissolved, and burned. The residue revealed phenolic compounds related to the resins used in wood adhesives, substances easily produced in any chemical works. The paper layers were identified as high-strength craft fiber, the same used for industrial packaging. The engineers documented each layer's orientation, noting the cross-grained pattern that gave the cylinder its rigidity. They counted 12 layers in total. When pressed together under heat, the result was strong enough to bear the weight of fuel and aerodynamic stress. To an outsider, it might have seemed an ingenious improvisation. To the Germans who studied it, it was something deeper, the embodiment of an industrial philosophy completely opposite their own. German engineering prized perfection. Tight tolerances, polished finishes, complex assemblies fitted by master craftsmen. American engineering, they now realized, prized sufficiency, designs that could be mass-produced by semi-skilled workers on identical machines across the continent. Inside one of Rechlin's briefing rooms, charts soon filled the walls. Lines of calculations traced the relationship between fuel load, engine consumption, and range. With the external tanks included, the P-51's operational radius extended past 2,000 miles. At cruise power, it could remain airborne for nearly 7 hours, long enough to escort bombers to Berlin, Leipzig, even as far as the Silesian industrial basin, and still fight its way home. The strategic implication was devastating. Every assumption underpinning the Reich's air defense network, the idea that Allied bombers would always outrun their escorts, had collapsed. From now on, every daylight formation entering German airspace would arrive surrounded by protective fighters from start to finish. Gallen's combat reports arrived from the front soon after. His personal account confirmed what the mathematicians had only guessed. The new Mustangs were engaging German interceptors over the capital itself and pursuing them well past the city limits. They were not throttling back to conserve fuel. They were fighting as if supply were infinite. That simple behavioral detail told the entire story. Range was no longer a constraint. The senior staff at Rechlin compiled a comprehensive memorandum. It contained not just performance figures but industrial estimates. How many tanks could be produced given American paper output? How many factories might be capable of the work? How many aircraft could be supplied weekly? The numbers staggered even the most seasoned analysts. The United States produced millions of tons of craft paper each year. If only a fraction of that capacity were diverted to drop tank manufacture, monthly output could exceed 100,000 units. Germany's entire fighter force at that moment numbered barely a few thousand aircraft. As those figures circulated through the Luftwaffe command chain, disbelief gave way to resignation. The engineers at Rechlin were no longer studying a piece of equipment. They were staring at a mirror reflecting the larger war. In that fragile paper shell lay the evidence of a nation whose factories operated without fear of bombing, whose labor supply remained abundant, whose raw materials arrived by the shipload. In contrast, German production lines groaned under shortages of everything: aluminum, copper, fuel, even trained machinists. Skilled toolmakers had been drafted into combat or killed in raids. Assembly halls relied increasingly on forced laborers unfamiliar with precision work. Each new aircraft that rolled out of a German factory represented months of strain. Each new American fighter represented hours. As the Rechlin team finalized its report, Allied air activity intensified overhead. The sound of distant engines had become constant, an airborne tide rolling east every morning and west every evening. The engineers often paused their measurements to step outside and watch the contrails spread across the sky like white scars. Somewhere among those vapor trails flew aircraft identical to the one disassembled in their hangar, carrying under their wings the same disposable tanks they had just weighed and measured. By late March, Luftwaffe intelligence had traced the origin of the paper tank concept to British research in 1943. The design had been adapted and mass-produced in both Britain and America. What began as a resource-saving measure for the Royal Air Force had become, in American hands, an instrument of industrial dominance. The British had invented, the Americans had multiplied. That pattern repeated across every technology the Germans examined. Radar sets simplified for assembly, radio components standardized for interchange, aircraft engines built from modular sections that could be replaced in minutes rather than hours. The insight settled over the Rechlin staff like a slow, cold realization. They were not simply outfought, they were outmanufactured. When the first completed summary left Rechlin for Berlin, it carried a quiet warning in its final paragraph. The opponent's industrial system demonstrates an ability to adapt production methods independent of material scarcity. Their use of non-strategic resources to replace metals indicates excess capacity, not shortage. This development must be regarded as strategically decisive. The document vanished into the bureaucratic tide of reports flowing toward the Reich Air Ministry. Whether it reached the attention of Göring or any senior staff was uncertain. But the engineers knew the truth. They had touched it with their own hands, light and fibrous, smelling faintly of resin and fuel. Each evening, as the day's work ended, the hangar doors were rolled shut to seal out the cold. Beyond the perimeter fence, the countryside stretched silent and gray, broken only by the distant echo of anti-aircraft fire. Sometimes, when the wind carried the sound just right, the men at Rechlin could hear the heavy rumble of Allied bombers somewhere above the clouds, beyond visibility, yet unmistakable. They would glance toward the sound and imagine the scene, the bombers droning in formation, flanked by long-legged fighters gleaming silver against the sun, carrying their fragile paper tanks into German airspace. No one said it aloud, but everyone understood what it meant. The Americans had achieved what the Luftwaffe once claimed for itself, command of the air. As March turned to April, Rechlin's testing continued. Other captured aircraft, other fragments, endless data. But beneath the technical routine, a quiet fatalism took root. The engineers now knew that no amount of craftsmanship could bridge the gulf of capacity they had glimpsed. The paper tank was proof that the war had entered a new dimension, one where numbers and logistics ruled above genius and bravery. Outside the laboratory windows, spring approached. The snow melted from the runways, leaving dark streaks across the tarmac. Supply trucks grew fewer. Fuel shipments arrived late, or not at all. Even test flights were reduced to conserve aviation spirit. Inside, however, the dissection of the Mustang continued with mechanical discipline. Every bolt, every bearing, every strip of insulation was catalogued. The technical notes filled hundreds of pages. But within the pages, a single theme repeated again and again: efficiency through scale. By the end of the month, the engineers had stopped referring to the captured fighter by its model number. They simply called it the American machine. To them it symbolized not a single design, but an entire civilization of production. They had entered March believing they could still outthink their enemy. They ended it knowing they could not outbuild him. By April 1944, the pattern was unmistakable. Every day that Allied formations crossed into German airspace, they stayed longer, struck deeper, and returned untouched. The Luftwaffe's defensive strategy, once built around timed interceptions and precise fuel calculations, was unraveling. Now the bombers no longer arrived alone. They came wrapped in an unbroken cordon of silver fighters whose range seemed endless. For German commanders, the change felt less like a tactical shift and more like the slow extinction of control over their own skies. At Rechlin the examinations continued, but their purpose had changed. No one still believed that reverse engineering a Mustang or copying a paper tank could alter the course of the war. The work had become archival, an effort to document what had already defeated them. Technicians logged every dimension, every chemical property, every note of performance, as though preserving a record for whoever might someday read it in a language not yet decided. The atmosphere was that of an autopsy, not a discovery. The factory rhythm that once pulsed through German industry had slowed to a heartbeat. Bombing raids struck aluminum foundries in the Ruhr, rail hubs at Leipzig, and the synthetic fuel plants that had fed the Luftwaffe since 1940. Where once convoys of tanker trucks rolled daily into Rechlin, now only a few arrived each week. Engines were tested on rationed fuel measured in buckets. Pilots preparing for evaluation flights waited days for permission to start their engines. Even the sound of aircraft taking off, a constant for years, grew rare enough to draw silent attention whenever it broke the afternoon air. In the headquarters at Berlin-Tempelhof, senior staff studied the same numbers that the engineers at Rechlin had calculated. They saw what those numbers meant, but could not change them. American production of aluminum now exceeded 1 million tons per year. Germany's had fallen below a quarter of that. While German factories struggled to deliver 600 fighters a month, North American aviation alone was producing nearly that number of Mustangs from 2 plants. The Americans built in months what Germany could not replace in a year. For officers who had come of age under the doctrine of technical superiority, this reversal was incomprehensible. German aircraft still boasted finer gun sights, higher precision engines, better climb rates at certain altitudes, but none of it mattered when their squadrons dwindled and replacements arrived half-trained. Instructors who once logged 300 flight hours for cadets now managed barely 50. Every engagement cost pilots who could not be replaced. The Luftwaffe was eating itself. Back at Rechlin, the paper tanks became teaching tools. New arrivals, mechanics, flight engineers, young draftsmen, were shown the laminated shells as symbols of adaptation. The instructors pointed out the cross-grained paper layers, the resin seams, the simple brass fittings. They explained how 2 of these fragile-looking cylinders had carried a fighter to Berlin and back. The lesson was not technical, it was philosophical. Strength, they realized, did not always reside in hardness. It resided in the capacity to multiply simple things endlessly. By summer, the significance of that insight was evident in the sky itself. Each dawn brought the thunder of bomber engines from the west. The contrails formed early, stretching in geometric lines until the horizon looked penciled with white scars. Civilians learned to distinguish bomber formations from escorts by the spacing of the trails. When the shorter, tighter lines appeared among the larger ones, people said quietly, "The long-range fighters have come." And always, after the formations passed, the countryside below was littered with the remains of what Rechlin had first examined months earlier. Silver-painted cylinders lay in forests, rivers, and open fields. Children mistook them for unexploded bombs and reported them to police. Local officials issued notices explaining that the objects were empty fuel tanks, not weapons. The reassurance did little to calm the deeper unease they provoked. To a farmer looking up from his ruined crops, the sight of hundreds of enemy aircraft discarding equipment as casually as trash was unbearable proof of imbalance. Germany was fighting with ration coupons. Its enemies were fighting with abundance. In July 1944, attrition reached its peak. Luftwaffe losses in the West exceeded 350 fighters a month. Many went down before ever firing a shot, intercepted by Mustangs whose pilots waited above the bomber streams like hawks circling a flock. Fuel shortages forced commanders to cancel training flights, then combat patrols. Entire squadrons sat grounded while the enemy ruled unchallenged overhead. The defensive system that had once terrified Europe now existed mostly on paper, blueprints, rosters, and reports written by men who no longer had planes to command. Inside Rechlin's administrative building, the final technical report on the Mustang's fuel system was typed, bound, and stamped in late January 1945. It ran more than 100 pages and concluded with a single paragraph that condensed an entire war into 2 sentences. The introduction of the P-51 fighter, equipped with external cellulose fuel tanks and powered by the Merlin engine, grants the enemy complete operational freedom over the German interior. Our resources are insufficient to counter this development. Defensive victory is no longer attainable. Few who read those words doubted them. The document was filed, copied once, and sent to the archives. Within weeks, Allied bombers destroyed the building that stored the original. The copy survived only because it had already been moved to a bunker outside Berlin. By February, Soviet troops were approaching the Oder. Rechlin Lars lay directly in their path. Engineers burned sensitive files, dismantled testing equipment, and buried crates of film negatives in the frozen soil behind the hangars. When the Red Army arrived 2 months later, they found little more than shattered runways and empty test cells. What remained of the captured Mustang had been destroyed by its own examiners, piece by piece, until nothing useful could be seized. The paper tanks were thrown into a pit and set alight, their resin skins curling and blackening before collapsing into ash. It was a small act of defiance, a final refusal to let even scraps of discovery serve another master. The war ended in May. Germany's surrender left Europe draped in silence where engines had once roared. Factories that had labored through endless nights stood gutted, their machine tools hauled away or buried under rubble. Yet fragments of Rechlin's work survived: photographs, diagrams, notebooks carried west by engineers seeking protection from Allied intelligence teams. Many of those men would later find themselves working in foreign laboratories, applying what they had learned not about aircraft, but about efficiency. Their wartime study of a paper fuel tank became a lesson in design philosophy. Simplicity is power. Across the ocean, in museums and private collections, a few examples of those disposable tanks endured. Visitors often mistook them for metal until they touched the surface and felt the faint grain beneath the paint. Curators explained how they were built from layers of craft paper bonded with resin, how they held 100 gallons of fuel, how they were used once and discarded. What the placards rarely mentioned was the effect those humble objects had on the men who first examined them in 1944. To those engineers, the tanks had revealed the true nature of modern war, not a contest of courage or invention, but of systems, supply chains, and the capacity to turn ideas into millions of identical artifacts. Long after the smoke of that war cleared, the Mustang continued to fly in distant skies, from the mountains of Korea to the airshows of later generations. Its beauty and speed became symbols of a bygone era, but the deeper legacy of its range remained tied to the story of the tanks that hung beneath its wings. They were never glamorous, never celebrated, yet they had carried history's weight in their thin paper walls. Every generation rediscovers the paradox that those tanks embodied, that the most decisive tools of victory may appear fragile, even trivial, until multiplied beyond counting. A single sheet of paper is weak. A dozen layers, cured with heat and resin, can carry a fighter across a continent. So too with nations. Strength arises not only from brilliance but from organization, the patient alignment of resources, factories, and hands. When the engineers at Rechlin realized that truth in the spring of 1944, it came not as revelation, but as surrender to mathematics. They saw that their enemy's advantage was not in any one airplane, nor in a secret technology, but in the collective hum of countless assembly lines running day and night across an ocean. Against that rhythm, even courage had limits. Today, the story of those examinations survives in scattered archives, in the memories of men long gone, and in the relics preserved behind museum glass. Each time a visitor pauses before a pale, silver-painted cylinder, they are looking at more than an artifact. They are looking at a message encoded in cellulose and resin, a reminder that wars are decided not only by the weapons themselves, but by the minds that choose how to make them. For the Luftwaffe engineers who peeled back that first layer of paper at Rechlin on March 10, 1944, the discovery marked the moment when the future became visible and defeat no longer a possibility, but a certainty. They did not know it then, but the smell of fuel and glue in that hangar signaled the beginning of the end. The sound of distant engines that day was not merely another raid. It was history closing in, borne on wings that reached farther than anyone in Germany had believed possible, lifted by nothing more than air, aluminum, and paper.